Say, if I wrote that down on a sheet of paper, would you think that the 3 is shouting? Or maybe I was really excited about writing a 3? No, you would actually have to write the answer, which is 6. See this exclamation point after a number? That means factorial. And what that means is you multiply 3 times its next lowest number, times its next lowest number until you get to 1, and then you write down the answer. 3 times 2 times 1, which is 6. All right, let's take a look at 4 factorial. What would that be? That would be 4 times 3 times 2 times 1. And if 4 times 3 is 12, times 2 is 24, times 1 is 24. So that would equal 24. What do you think 5 factorial is? It's going to be 5 times 4 times 3 times 2 times 1, right? But we've already done 4, 3, 2, 1, so we'll just multiply 24 by 5, which is 120. So you might be thinking, that's great, but when am I ever going to use this? Let me show you. Suppose you go into an ice cream store and the man behind the counter says, okay, who wants their ice cream first? And you say, me! So you get your ice cream first, and then your little brother, who's got spiky red hair, says, okay, I'm next. And then your little baby sister, who's got little pigtails, says, okay, I'll go last. And you all get your ice cream in this order. You got it first, brother second, sister third. Now my question is that the only order you could have gotten your ice cream in? No, of course not. You could have gone first, and then who could have gone? Yeah, your sister could have gone next, right? And then who could have gone last? Yeah, your brother, right? Spiky hair. But is those the only 2 orders? No. Who could have gone first? Spiky hair, right? Could have gone first, and sister could have gone second. And then you could have gone last with the long hair. There we go. Is that all the possibilities? No, not quite yet. Spiky hair could have gone first, and then you could have gone second. And who would have gone last? Yeah, baby sister, right? With the little pigtails. Okay. Is that the only possibility? No. Who hasn't gone first yet? Sister. Okay, so sister could go first. Okay, and brother could have gone second. And then you, with the long hair, could have gone last. All right. So let's see. You've gone first twice. You've gone last twice, but you've only gone in the middle once. So let's see if we can figure out that last combination. Do you see it? There's a pattern. Sister goes first. Who goes second? You do. Whoops. There we go. And who goes last? Brother. Okay. Are those all the possible combinations? The answer is yes. How many different combinations were there? 1, 2, 3, 4, 5, 6. There were 6 possible combinations. How many people were getting ice cream? 3. Do you see anything familiar? This is where factorials come into play. The reason that 3 factorial is equal to 6 is that if there are 3 of you in line for ice cream cones, there are 6 different ways that you could line up to get them. Suppose there were 4 of you for ice cream. How many different ways could the 4 of you line up? I'll give you a hint. It looks like 4 factorial. Yeah, it would be 24. And if you had 5 people, how many different ways are there to line up? There's 120 ways. Do you see how they start to get out of hand? Think about this. How many cards are in a deck of cards? Well, there's 52 if you take out the jokers, right? How many different possible ways are there for a deck of cards to be stacked up? Meaning, if you shuffle a deck of cards, what's the probability that the cards will end up in one particular order? Well, the answer is going to be 1 over the total number of card combinations possible. And so let's find out how many card combinations are possible. All right. So that's 52 times 51 times 50 times 49 times 48, ... all the way down to times 1, right? So an easier way to write that is 52 factorial. What do you think this number is? It is a very big number. It's 80 million trillion, 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 trillion. So the chance that your cards are in one particular order is 1 in 80 million trillion, 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 trillion. So next time you shuffle a pack of cards, think about this. It's very likely that nobody in the history of the universe has ever had exactly those cards in exactly the same order that you have them in right now. That's what makes cards so great for playing games with. Now, on a last note, you might be wondering, what is 0 factorial? And the answer to that, it's equal to 1. Now, having 0 people line up for ice cream cones sounds kind of crazy, and it doesn't help when trying to figure out how this could possibly be true. So let me show you how 0 factorial is equal to 1. You might want to get out your calculator. 6 factorial divided by 5 factorial is equal to what? Remember, this is 6 times 5 times 4 times 3 times 2 times 1 divided by 5 times 4 times 3 times 2 times 1. You can cross out any duplicates, so the 3's, the 4's, the 5's, all cancel out. So 6 factorial divided by 5 factorial is going to be 6. Okay, so what's 5 factorial divided by 4 factorial? Yeah, that's going to be 5. What's 4 factorial divided by 3 factorial? Okay, that's going to be 4. How about 3 factorial over 2 factorial? That's going to be 3. How about 2 factorial over 1 factorial? What do you think? That's going to be 2. So let's continue the pattern. What is 1 factorial over 0 factorial? What does it have to be if you continue the pattern? It equals 1. Now, if it doesn't equal 1, the pattern breaks down, and that makes mathematicians very sad. Because 0 factorial has to equal 1, because 1 divided by 1 is the only way to get 1 here. Can you follow this? If you can't, don't worry. It'll make sense to you someday. But even if it doesn't, you can still get in line for ice cream, whether or not you understand anything about factorials.